Welcome, young mathematicians. My name is Alyssa Howell, and I'm the Secondary Director for Mathematics in Houston ISD. We had so much fun this school year that we've extended our learning together into the summer. Each week of summer school, we're going to focus on one activity from each of the grade levels. Let's get started. In this portion of the HISD at Home summer school lesson for grade 6 in week 1, we are going to focus on operations with rational numbers. This activity is from Thursday's lesson. The learning goal for this week is that you are able to multiply rational numbers fluently. And we're going to focus on this week decimals and fractions, keeping in mind that rational numbers include a lot more other types of numbers, but we're going to focus on decimals and fractions. So the first thing that we're going to use in the lesson on Thursday are what we call block 10 blocks. And so you can, if you want, you can cut these out. You can print them off the internet and cut them out. But I think that this is a lot of cutting and they're very little, so they're difficult for me to work with. So what I like to do is I like to use some good old-fashioned graph paper. So you'll notice here that I've used my graph paper and I want to focus on the different parts. One large square is going to represent one whole unit. And this is important because, as you can see along each edge, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 along this edge and 10 along this edge. The whole thing is one unit. So that means each little piece right here, if I've divided it into 10 sections, is 1/10 long. 1/10 long. And if I have 10 tenths and 10 tenths, I get an entire one whole square that has 100 little squares in it. And that's important because when I look at this rod right here, it is one whole length, but it's only 1/10 wide. That's why it's 1/10. Its area is 1/10. It takes 10 of these rods to make up one whole square. And similarly, one small square that's 1/10 wide and 1/10 in length makes 1/100th. And that's why there are 100 little squares in here. So this is important because we're going to use these today to multiply our decimals. So let's look at one of our first examples that we can do. If I want to multiply 0.6 times 0.2, I need to create one of my pieces. Now, I wished that I could use a whole or 1/10 or 100th, but that's not how this is set up. It's set up with 0.6. Now remember, I told you that each of these is 1/10 long. 1, 2, 3, 4, 5, 6 tenths times 2/10. So the way that we multiply these is that, and remember again, I'm using graph paper. Here is my 0.6, and I'm going to multiply that by 0.2. So that I have 0.6 this direction, and I have 0.2 this direction. And now I have to figure out how I'm going to fill in a full rectangle. Well, we fill it in a full rectangle. And now if I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12. And do you remember what each of the little boxes represents? If you don't, we can go back to our key Each of the little boxes represents 1/100th. So I have 12 of the little squares, or 12 hundredths. Remember, tenths place, hundredths place. So 0.6 times 0.2, or 6/10 times 2/10, is 12 hundredths. Now, this is important because we're going to start shifting away from this representation with our boxes and squares, and we're going to move towards graphic organizers, such as this one. And so what happens is I've placed one of the factors across the top, and I placed one of the factors along the edge. And now I multiply to fill in the spaces in between. 0 times 0. Do you know how much that is? That's right. It's just 0. Now we'll multiply 0 times 2/10, or 0.2. That's also 0. It's one of our properties of multiplication. Now let's multiply 0.6 times 0. Again, that's just 0. And then what happens when I multiply 2/10 times 6/10? That gave me 12 hundredths. And we add together all of the boxes we created. Now, I know this seems silly. It seems very obvious, but we're going to go towards much more complicated examples. Let's try the next one. If I show you this figure, do you know how much this represents? I have one big piece that's blue, and I have 3 of these little pieces that are pink. Do you remember how we designated these? This was a 1/10 on each side, 10/10, and this was a 1/10 on each of these little sides, so there were 10/10. So this is 1/2. This piece is 1 in length and a 1/10, in width. So this is 1/10, 1/10, and 1/10. This whole piece represents 1 3/10, or in other words, 1.3. So let's write that down. 1/2 3/10. Now let's look at this next number. If I have this, I have 2 big blocks, 2 whole blocks. That's a 10/10 by 10/10, 10/10 by 10/10. 1/2 plus 1/2. Do you know how much that is? That's right. It's 2 whole. So let's look at how we might multiply using our base 10 blocks. If I want to find out how much 1.3, or 1 3/10, times 2 represents. So I have my 1 3/10, and I'm going to move it up just a little bit. And I have, notice how I overlap here. I have my 2 holes. I want to make this a full rectangle. Oh, but I'm missing something down here. Oh, that's right. I can put this into here so that I now have 1 hole, 2 holes, and how many tenths do I have? 1, 2, 3, 4, 5, 6. 6/10. So my answer is 2 whole and 6/10. 2 whole and 6/10. And this is important because remember that when we're going to move it into our block diagram, we put 1 factor across the top, 1 factor along the side, and now I multiply. 1 times 2, 2 times 3/10. Oh, and that's all there is. So I add the pieces together and I get 2.6, 2 6/10. Now that we have completed this activity, you should be able to say, I can multiply rational numbers fluently. You have completed your writing task for the day, and that is going to be used as evidence for your learning. Don't forget, there are other activities that you need to complete for grade 6 this week. Thank you for joining me. I'll see you next week. Now I'll send you to Jonathan for the grade 7 activity.
Welcome, young mathematicians. Thank you for joining us again today. My name is Mr. Denning, Teacher Development Specialist at Houston Independent School District. For today's portion of HISD at Home Summer School for grade 7, week 1, we'll be working on operations with rational numbers. This is add, subtract, multiply, and divide numbers that look like this. Specifically today, we'll be working on lesson 2 from week 1. This allows us to make up real-world stories using math expressions and explain it in 4 different ways. So let's get started.
Don't forget our rules about signs. If we have 2 positive numbers, our answer will be positive. But if we have different signs, we need to check the number line.
So our student lesson from day 2 is to be able to add and subtract using number lines and chips. You'll notice the chips we're using are going to be circles today, right above. So the first example that we're going to do will allow us to take our paper, fold it once more, and you'll have all of your corners touching like this. Please make sure that on the outside you have 1, 2, 3, 4 flaps, and on the inside you're going to fold in a triangle like this. Now unfold your paper and note you have the example that we have up on the wall here. So let's get started. So our first example today comes from our story. We owe $7 and we paid $3. How much money do we have left to pay on the bill? So one way that we can write this in our very center of the problem here is start with the first number, 3, and it says that you paid. So we're going to put that in as paid, positive. The next number you see says you owe 7. So we need to create a way to owe 7. And instead of positive, I'm going to put negative. The question is, how much do you still owe on the final bill if it was originally 7 and you paid 3? So let's quickly take a look at an example where we can use our math circles. Notice we have 1, 2, 3 that are positive. And in our math expression, we also have 7 that are negative. -1, -2, -3, -4, -5, -6, -7. To make sure you get the right answer, what you want to do is match up your pairs of positives with negatives. Continue matching until there's no more. That's how you know when to stop. The remainder of the problem is your answer. So let's count them up. First, do you think we should use positive or negative as our final answer? You're right, it's negative. Next, let's make sure we count everything. 1, 2, 3, 4. How do you say the final answer? It's -4. Another way to say this is +3 minus 7 is -4. +3 minus 7 equals to -4. All right. Let's make sure we can see this on a number line. If you listed all the numbers on your line from 0 all the way out to 3, and on the other side, all the way out to -4. We know the problem asks us to start at +3. So we will start here at +3. They asked us to go to a -7. So we're going to go in the minus direction. We're going to use -7 to move our arrow. Our arrow stops at -4. That means our final answer is -4, and we'll circle it at the bottom. The last step that we have to take is to explain that +3 minus 7 is -4, because 3 and -4 are 7 places apart on the number line. Great. And then he descends, which means he goes down another 30 feet. Then he descends another 10 feet. Remember, in this upper box, what we want to do is show how we can model this using our algebra chips. So we're going to use our math chips here, and we're going to show that we started at -20. See, here's -20. Then she descends 30 feet. So we put in -30. The diver descends another 10 feet. Remember from our last examples, we were looking for things to match, positives and negatives, but we don't have anything to match here. So we're ready to make our final answer. 10, 20, 30, 40, 50, 60. And in front of it, we put our negative sign. What is the final depth? That should be 60 feet, right? We're negative 60. So in our story, we can put negative 20 minus 30 minus 10 equals to negative 60. And in our answer, the way we want to explain this to everybody is that the diver starts at minus 20 and ends at minus 60. So the diver is 60 feet below the water. All right.
Wow, that was great work today. Now remember, Monday is when you do the Stack the Jack activity. Tuesday, that's this activity. Wednesday, you're going to complete your graphic organizer. Thursday, we're going to do some math practice. And Friday, we're going to be virtual. I can't wait to see you next week. Have a great rest of the day. See you next week, class.
Welcome, young mathematicians. We are so excited to have you. We had such a great time during the school year that we thought we would extend this learning through summer school. Over the next few weeks, we're going to be going over key activities from the summer school curriculum brought to you by Houston ISD. You can get these activities through your teacher or by going to the HISD at Home website. Here we go. Before we get started, let's review our guiding questions. Our first guiding question is, how can you represent and solve equations with the variable on both sides? And guiding question number 2 is, what method can be used to isolate variable terms on one side of an equation? Now that we've reviewed our guiding questions, which we'll return to at the end, let's go ahead and look at some examples. All right, so we're going to get started by reviewing the first problem provided to you on day 1 of summer school, and that problem is represented using these cups and these pieces of paper. So let's go ahead and take a look at what we have. If I look on the left side of the equation, you'll notice that I have 1, 2, 3 cups, and those cups represent x. So on the left-hand side, I have 3x plus 1, 2, 3, 4, 5. This pin right here represents my equals sign. So this is my left-hand side of the equation. This is my right-hand side. And you'll notice on here, I do have 2 cups, but they're turned over because each turned over cup represents a negative x. And then I also have negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 3x plus 5 equals negative 10 minus 2x. All right, think back to our second guiding question. What method can be used to isolate the variable terms on one side of the equation? So what we want to make sure we do is that we only have terms with an equation on one side. So what I like to do is I like to look at the 2 terms and see which one has a smaller value. So I have 3x and I have negative 2x. Negative 2x has the smaller value. So I'm going to create 0 pairs so that I can cancel this term out. Now a 0 pair is one positive and one negative. I want you to think about the temperature. If the temperature increases by 1 degree, but then decreases by 1 degree, we're back where we started. Likewise, in football, if a player runs 1 yard, but then loses 1 yard, He's right back where he was when he started. So we are going to add a positive x and then another positive x. And we have now created a zero pair. We have negative x and positive x, and those two cancel out. Negative x, positive x. These two cancel out. But as many of you know, I cannot just add whatever I'd like to one side of the equation. We often talk about this as a balance scale. If I add something to one side, I have to make sure I add it to the other side. So let me go ahead and add a positive x here, and then another positive x. All right, I've added 2 positive x's to the right side, 2 positive x's to the left side. Now let's go ahead and look at our zero pairs. I'm going to make sure I add what I just did. So I added 2 x's. All right, let's see what happens. Now on this right side, do I have any zero pairs? Remember that zero pairs are made up of a positive and a negative. And the answer is I don't. I only have 5 positive x's. Plus 1, 2, 3, 4, 5. Equals, I still have 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. But now I have a negative and a positive x which cancel out, and a negative and a positive x which cancel out. So on my paper, I can go ahead and draw a line because I've canceled those out. All right, here's what we're left with. 5x plus 5 equals negative 10. And as many of you remember, we want to make sure that our x's are on one side and our numbers are on the other side. So I'm going to have to do something with this positive 5. What do y'all think we could do? If you said add negative 5 to make zero pairs, you are correct. I'm going to add 5 negatives. And of course, if I add it to the left side, you all know I'm going to have to add the same to the right side. 1, 2, 3, 4, 5. Okay, let's write down what we just did. So I added a negative 5 to this side, to the left side, and I added a negative 5 to the right side. Okay, I still have 5 x's. But I do have some zero pairs on the left side that I can take care of. So I have 1 zero pair, 2, 3, 4, 5. All right. So a positive 5 plus a negative 5 cancel out. There's my equal sign, right? Now let's see. Do I have any zero pairs on the right side? I do not. Instead, I have negative 10 plus negative 5, which is going to give me, how many do y'all see there? Negative 15. All right, the last thing I need to do is figure out how much one of these x values is worth, okay? So I am going to divide all of my numbers on the right equally between my x's. Here's how this is represented. On my paper, I'm dividing by 5. And you might wonder why I'm dividing by 5, but it's because I'm taking negative 15 and I'm dividing it equally amongst these 5 cups. So let's do that. 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3. Now each cup has the exact same amount, and I know that's true because when I work it here, 5 divided by 5 is 1, and 1 times x is just x, equals, so I have 15 divided by 5, which is 3, but what kind of 15 did I divide? Did I divide a positive 15 or a negative 15? I divided 15 negatives by 5 cups. So inside each cup is negative 3. And I know that's true because if I look at a cup and I take it out, I have 3 negatives. So that's how we solve that first problem. We're going to go through one more in just a minute. Thank you guys so much for joining me today. Let's quickly review the guiding questions. So guiding question number 1 was, how can you model and solve equations with variables on both sides? I hope you see now that using simple cups and pieces of paper, or even drawing out the problem using positives and negatives on your paper, can help you solve an equation with variables on both sides. In guiding question number 2, what method can be used to isolate the variable term on one side of the equation? So the best way to approach that is to find the variable term that has the smaller value and add either positives or negatives to make 0 pairs. And of course, whatever you do to one side of the equation, make sure you do it to the other side of the equation. Okay, I'll see you next time.